Hi, today I'll describe a recursive function that determines if a varied binary tree is actually a binary search tree. My approach uses a recursive function that validates each node against allowed ranges. For a binary search tree, every node value must be greater than all values in its left subtree and less than all values in its right subtree. Rather than comparing to every node, we pass down allowable minimum and maximum values as we traverse the tree. The base case is when we reach a null node, we return true. This makes sense because an empty tree or an empty subtree is trivially a valid BST. There is nothing to violate the BST property when there are no nodes to check. For recursive case, we first check if the current node values violate the BST property. It must be greater than the minimum allowed value and less than the maximum allowed value. For the root node, we use negative infinity and positive infinity as the initial bounds. The current node is varied. We make two recursive calls. For the left subtree, we update the maximum bound to the current node's value because all left children must be less than this node. For the right subtree, we update the minimum bound to be the current node's value because all right children must be greater than this node. The function returns true only if both recursive calls return true. Let's trace through a simple example with root value 10. We call validate on the left subtree with max equals 10. The left children value must be less than 10. If it is 5, that is valid. We then call validate on its left subtree with max equals 5. And if it is right subtree, with min equals 5 and max equals 10. If we ever find a node with value 12 in the left subtree, we would return false because 12 is not less than 10. Thank you.